This video will review the Excel skills you need to complete case number 6. Case number 6 is about capital investment. A capital investment is an investment into something that costs a lot of money and that lasts a long time. So here's an example. A manufacturing company is thinking of purchasing a new machine for $25,000. The machine will be useful for 10 years, after which it will be sold for $2,000. But more importantly, that by buying this machine, there will be cost savings of $4,200 every year for the life of the machine. So the question is, should the company buy the machine if the required rate of return on any capital investment is 10%? So we begin by entering the assumption values at the top of the spreadsheet. The individual single numbers that will be used in formulas and that might change in the future. So those are the 4 assumption values. Now we have to use cell addressing in our formulas down below that reference these assumption values. This is very important. So in year 1, the cash inflow or the cash savings come from cell B8. Now I know I'm going to copy that very simple formula across until year 10, so I will make B8 an absolute cell reference first, and then I can click and drag the fill handle all the way across. It's the same amount of money, same amount of savings every year. Now in year 10, however, the machine is sold, and so we can add the salvage value, or what's left over, the money that we get by selling the machine, to the year 10 amount. Now we need to use a function that will take this present value and all of these future values and convert all the future values into present values and add them all up as one sum of money. And that function is called the NPV function in Excel. All right, so let's fill in the 3 argument boxes. The rate is a percentage, so it's the rate of return, in this case 10%. And the value is a range of numbers that are equally spaced in time, so we simply select the entire row of numbers in row 14. And that's all. That's all we need. Our answer is down here below already. So what this function does is it converts every future value into a present value and then adds all those numbers up. So this one amount of money, this $26,578 today, represents this future amount of money going up till year 10. Now we have to then compare that to the cost of the investment, or the cost of the equipment, so which is a present value. That's how much the equipment costs now. And we can compare by taking the money coming in, or the cash savings, less the money going out, which is the cost. Coming in minus going out. The difference, the net present value, is a positive amount of money. And that means that the new machine will generate at least a 10% return on investment. It will be more, but we don't know exactly how much more. But because the net present value in dollars is greater than 0, then that means the rate of return on investment will be met. The other way of looking at it is in a ratio format. So you take the present value of inflows divided by the cost. So if the two numbers are the same, the profitability index is exactly 1. If the profitability index is greater than 1, again, that means that the rate of return on investment is greater than the 10% that was used in the original calculations. If the profitability index is less than 1, or the net present value is negative, it's below 0, that means the investment should not be made. But that doesn't mean the investment's not profitable. It means that the rate of return has not been met. Now, a data table is a form of what-if analysis. So what if the cash savings were $3,000 rather than $4,200? What if the cash annual savings were $4,000, $5,000, $6,000? So we're playing around with the original assumption values in a data table. We create a row of numbers and then we create a column of numbers in this format. So these percentages represent rate of return on investment. Now in the corner box here between the two sets of numbers, we must have a formula. And the formula we will be recalculating will be the profitability index formula that's already given in cell B18. So we've set up our table. Now we're going to highlight the table, all of it, and go to Data, What If, Data Table, and fill in the two dialog boxes. The row input cell is the original assumption value related to the row of numbers in the table. And the column input cell is the original assumption value related to the column of numbers in the table. And when you click OK, I will format these numbers so they'll be a little easier to work with. You can see that all these numbers inside the table are different values of the profitability index. So we don't have the original value here, but if we did, we'd see 1.03. So what this means that every number here that's greater than 1 means that we've achieved the rate of return on investment that's required. And every number less than 1 means we have not achieved the rate of return that's required. This is a great opportunity to use a little bit of conditional formatting. So we can format these numbers that are greater than 1 and make them green. Green means go. So how do we interpret a data table? So you can see that if this investment only makes a savings of $3,000 a year, then the rate of return will not even be 5%. So under neither of these situations should you make the investment. But if the annual savings go up to $4,000, definitely will make a 5% return, and all the way up to a 10% return, but you will not make an 11 or 12% return. If the numbers go higher, 5,000 or more, you can see profitability indexes are all greater than 1, so all of those rate of returns of investments will be met. And that concludes the review of the Excel skills that are required for Case 6.